Welcome to Spring LIB.
Okay, so I'm going to start with the skeleton. H2C bonded to C, bonded to CH2. So a C with two H's, with a single bond to C, with a single bond to C, which has two H's. And I'm going to draw its Lewis dot structure, so I need to add either lone pairs or additional bonds here, right? And so how many electrons do we need to have in total? We need to have 4 times 3 for our carbons, that's 12 electrons, and then 4 times 1 for our hydrogens, that's a total of another 4 electrons for a total of 16 electrons. How many do I have here? 2, 4, 6, 8, 10, 12. Okay, so I need to add 4 more electrons. How should I add them? Well, let's notice that this carbon is 2 electrons short of a full octet, so is this one, and this one is 4 electrons short of a full octet. So if I add a bond here and a bond here, everyone will have a full octet and everyone will be neutral. So that's what I'm going to do. And that will give me my total of 16 electrons. Okay. So a valence bond description of the bonding in electron, an allene. Right, so this is a sigma bond and a pi bond. This is a sigma bond and a pi bond, and each of these are sigma bonds. Okay. Then how can I describe the hybridization of any of the carbon atoms? Well, this carbon atom has 3 atoms that it's connected to, which implies that it's sp2. This one has 2 atoms that it's connected to, so it's sp, and this one has 3 atoms that it's connected to, so it's sp2. Okay, so 4 connections is sp3, 3 connections is sp2, and 2 connections is sp. Okay, so which orbitals are overlapping to produce what types of bonds? So this, I think, we can answer the last little bit with a better drawing. So we have the central carbon. We know it's sp hybridized. So here's an sp orbital, right? And then we have this carbon over here, which we know is sp2 hybridized. So it's going to have an sp2 orbital like that. Okay, and then each one is going to have a p orbital that's not hybridized, right? And those are going to overlap. Okay, so that's the bonding that describes this right there. Now on the other side, so this picture corresponds to this. On the other side, it's going to look much the same. We're going to have an sp hybrid here, an sp2 hybrid here, and of course each one will have its unhybridized p orbital, except for in this case it's actually going to be an unhybridized p orbital that goes into the front and back of the page. Right? So these p orbitals are up and down, and these p orbitals are front and back. So this is the sigma bond, and this is the pi bond. This is the sigma bond, and this is the pi bond.